So today I'm going to talk to you about a very cool project that I worked on. It's still ongoing, to be honest. About 2.5 years. Very complex project, a lot of moving parts, and I think it's very relevant to domains where labeling is very labor intensive and very expensive. So boosting human labelers with AI in the loop. So I'm gonna briefly describe Gong, who we are, what we do, and then the business problem that we tried to solve, how we solved it, how we actually solved it under the hood, and a little bit about what's next. So the two gentlemen here in the image are Amit Bendov, the CEO of Gong, and Elon Reshef, the head of product, and they founded Gong about just over 7 years ago because Amit, he was a CEO of Sisense, and they had a really bad quarter, and they were losing deals, and they didn't know why. And Amit asked the salespeople, what happened? Why are we losing deals? And all he could get was kind of assumptions, guesses, guesstimates, nothing data driven, nothing objective. So he partnered with Elon, and they founded Gong, which gives you clarity into what's going on in your customer facing conversations. So Gong captures phone calls, conferencing meetings, emails, data from CRM platforms like Salesforce or HubSpot. It puts it all in one place, analyzes it, and gives you insights into what's going on. Why are you losing deals? Which deals should you pay attention to? What are your top performers doing that your bottom performers aren't? How you can increase your revenue. So conversations, we help understand who spoke when, what did they say, what were they talking about, what was shown on the screen at that time. And we have about 350 employees here in Israel, about 1,200 worldwide, quite a big but also quite a small research team, thousands of customers, a lot of data that's being processed every day. So what's the problem? So Gong, it's part of it is just a call recording, right? And you can listen. That technology existed 7 years ago, 17 years ago, right? And you can also read the transcript, right? Automatic speech recognition is something that's got infinitely better in recent years, but it's been around, for a while, and you can read. But 37 minutes, are you really going to listen to the call or read that call? No one has time for that. Okay, so if you want to look into certain points of interest in the call, you can use keywords, right? Let's say I want to find places in the conversations where customers asked for a discount. I can look for the word discount. So we'll need a discount to proceed. I think without a discount, there's nothing to talk about. But we may also capture moments that were out of context, right? I got a major discount on Black Friday. That's not really what I'm looking for. So let's look for concepts, okay? So we can look for things like we'll need a discount to proceed, but also can you get us a better price? It's too high of a cost right now, etc. But a plot twist, okay? We let our customers create their own models. But why? Okay, so we have more than 3,000 paying customers, and each of them have their own needs. Some of them want to look at inventory management, others want to look at some very specific concepts like see social differently is a real sales motion of one of our customers. And Out of 10 customers that were design partners for this project, they pitched 20 concepts that they wanted to look in their own data, and there were 19 unique concepts out of the 20. And we're not experts, right? We don't know about the medical domain. We don't know about the nuances that our business users need. So we built smart trackers. It's a little bit of a sales video, but it's gonna explain in just over 90 seconds what smart trackers are.
Introducing Smart Trackers from Gong. These trackers identify when important concepts are discussed in your team's customer conversations. They work even when people use different words to say the same thing. For example, some buyers ask for a discount by saying, "How can we get a better price?" While others say, "Can you go any lower?" Rather than relying on an exact keyword match or outdated information in your CRM, Smart Trackers are a revolutionary, user-trainable AI solution that find exactly when important concepts were discussed, even if they're said in different ways, so you can spot risk, replicate best practices, and ensure the success of strategic initiatives. Take these steps to build your Smart Tracker. First, define the specific concept you want to track, like discounts, for example. Give us examples of sentences that represent this concept. Train the model by tagging the sentences according to whether or not they fit your concept. The more sentences you tag, the more accurate the model. Finally, review the tracker's performance. Satisfied? Go ahead and publish. Want to improve it? Continue training the model by tagging more sentences. Once it's published, you'll be able to start capturing these crucial moments and act on the information to close out more deals. Track the adoption of messaging. Spot risks and buying signals, and gain deeper insights into your team's customer conversations. Smart Trackers from Gong. They've got your back.
So, it's an important point to mention here is that our users are not, they're not data scientists. They're often not even technical. And giving them the power to build their own models is not trivial at all. So if that sounded a little bit simplistic to you, data scientists who know what training a model is, even choosing the right words to use, like what is training a model or what is tagging, is absolutely not trivial to the layman. So let's just go over what we saw here, right? The user inputs some initial queries. They go through labeling rounds, right? Bite-size labeling rounds. This was a very hard negotiation with our product and UX people, because we're having our users work for us, right? Well, they're working for themselves, but labeling is not always fun. And they're tagging based on their own data, their own instance. And then they can review the results and decide whether they want to continue labeling or if they want to publish this model. So what's actually going on under the hood? This is where the product slides end, and this is where me, the data scientist who doesn't draw very well, inserts the figures. So we have five steps here. We have a retrieval step. We sample from this retrieved data. These are the examples that we surface to the user for tagging. The user labels that. We use those to train the model, and then we iterate. We retrieve, we refresh our data set, surface more samples, and until the preview is satisfactory to the user. Okay, so adding initial queries. What does this mean? So this isn't. How many of you are familiar with NLP? Okay, not many of us, but about half. So like 5 seconds on text representations. So we take a sentence, say, how high a discount can you give me? And we throw this into an embedding model that creates a dense vector that represents the semantic meaning of that sentence. So close vectors will have similar meanings. Okay. So we embed the queries, the input sentences that the user provided, as well as all of her conversations. And these live in the same space. We retrieve KNNs from that large vector database, where we can also filter on metadata. So does this sentences that come from a certain business type, from a certain team, was it said by the company representative or the prospect? And what we do here is we're focusing our labeling on the relevant area of embedding space, right? Text is infinite, but we're focusing on our labeling efforts on where it counts. Next, we have a few thousand samples that we retrieved that are in the vicinity of our concept. How do we surface samples to be labeled by the users? So first, we want diversity, right? We don't want to show them exactly the same thing. That's not going to be very informative for our models. And we can choose diverse samples in the semantic representation space. And also our classification model itself creates a kind of warped representation. And we can look at diverse samples in that embedding space. We can also sample by model confidence. So I can target samples where my model doesn't really know what to say, or I can validate that my model actually knows what it's doing, and I can sample from high confidence samples. I can also look at places where there's a disagreement, where there's a very close semantic similarity, but the model says things that are different. So this illustration is one way to achieve diversity. We can cluster the embeddings, and we can sample from each cluster, not visit clusters more than we need to. And labeling. This is a little bit of a kind of UX slide, but this will be relevant to anyone who uses manual annotations. Giving the people the opportunity to say, I'm not sure, or to skip an example is crucial. It really kind of takes the load off. You know, people feel very, very responsible. I don't know. What do I say? Yes, no? Giving them that opportunity to say not sure will help you get better data. We don't really do much with these not sure labels, to be honest. They're silently discarded. But we could, right? We could maybe focus on these areas and provide more sampling around those areas. Training the model, as I said, we have labeling rounds where where users tag 25 sentences at a time, and we train the model, a transformer-based NLP model, after every batch, and that happens online. They wait about 1-2 minutes for the model to train, and then we also refresh the data set based on the new labels that were input. So we can target from the retrieval from that huge vector database. We can target different difficult examples close to the decision boundary, or we can also, as I said previously, we could also use some samples for validation to see if we're on track. And then reviewing results. Remember, these are non-technical users. We have to keep this very straightforward and very simple. We're displaying here samples that were positively predicted by the model, and we're precision oriented, right? They're not going to see what we didn't detect. They're not going to see recall measures here. But showing them, for example, an ROC curve, it's going to be Sophie's choice. They're not going to know, where to put that. Me as a data scientist, I often have, a lot of anxiety around choosing that threshold. What I was talking about was a feature that we have in Gong since at least 6 months. And we have 1,200 models and counting that were built by users. But this is also heavily used in-house for our own labelers. And at home in the lab, we can do more. We can have them label many more samples. We can use cross multi-company data. We don't share data between companies for privacy reasons, but we've built many text classifiers in-house based on this methodology, and we can build a training set within hours. It's even fun and addictive. Test sets, by the way, are a different story. They're created in a different kind of more rigorous manner. And one last thing, all we need to do to support a different language is to have a text embedding that supports that language. And what next? So 2 big things here, 2 big challenges that are still very much open questions, or something that I call, are we there yet? Which means some sort of progress report to our users. How many labels do we actually need in order to capture a certain concept? Should I continue doing another round? Will that be helpful? Will that improve the model by a lot, by a little? Can I measure if the concept is broad or narrow, if this is going to be a successful classifier or not? In general, evaluation in this very, very low resource setting is difficult. We have something like just over 100 labels for most of our models. The minimum that we set was 4 labeling rounds plus the input queries. We're building a text classifier on very, very little. I used to wake up in like a cold sweat every time a model was built. I was like, okay, is it working? And it's pretty amazing that it does. And another huge, mostly engineering, but also a research topic is scale. So this has been out for just over 6 months. We have 1,200 models and counting. You can extrapolate that in 2 years from now, we're going to have probably tens of thousands. That's a huge difficulty in terms of serving these. So what we're looking into right now is trying to shift the heavy lifting from the classifiers towards the embeddings, where if we have better embeddings, we can have lightweight classifiers that are much more easy to serve. That's it. Thank you.